Hi everyone, today we are going to cover lesson 3.5 and 3.6. We're going to be covering a lot of vocabulary, and so if you are unfamiliar with some of those vocabulary words, I recommend making sure you do the OMHS material, and I also provided you with an additional video just going through all of the basic circle vocabulary that you're going to be hearing me use. There's also a vocabulary sheet and a filled in vocabulary sheet on OMHS if you would like to reference those also. Please don't forget to take the attendance quiz and lesson check after you viewed this video. And remember that Unit 4 test has to be submitted in order to get credit for it. So if you haven't done or submitted the Unit 4 test, you need to make sure you do that so it's not showing up as a 0 in the gradebook. The notes for 3.5 and 3.6 are available on OMHS, and the key will be available later today also. So we're starting to talk about circles, a new shape, finally, right? A new shape to talk about. We're going to start by talking about central angles and arc measures. A central angle is an angle with its vertex at the center of the circle. The two sides of the central angle are radii, which is plural of radius. The sum of all of your central angles in a circle is 360 degrees. So in my picture over here, angle ABC is a central angle. B is the center of the circle, and so the angle ABC, its vertex is B, the center. We call that a central angle. The degree of the arc formed by the endpoints of a central angle is equal to the degree of the central angle. So what that means is since this angle is 84 degrees, that means the measure of the arc is also 84 degrees. We measure arcs in degrees. So the measure of arc AC is 84 degrees. So then we can also figure out the measure of arc ADC. Okay, remember that the measure of a circle is 360. So if I know this piece is 84, then I can do 360 minus 84 to find out the missing piece over here, which is 276 degrees. Okay, hopefully you've watched the vocabulary video, or at least looked at the vocabulary words. Please remember that this little m means measure. We learned that in Unit 1. And this arc symbol means arc. So I'm talking about the measure of arc AC. Remember that we name a minor arc with 2 letters. A minor arc has a measure less than 180. And we name a major arc with 3 letters. And a major arc has a measure greater than 180. Knowing what we know about central angles will allow us to solve some of the problems that we see here. Okay. So I know that N is the center of my circle, which means that angle JNK is a central angle. So if the measure of this angle is 21, then the measure of this arc is 21 degrees also. Remember that vertical angles are congruent. So if this angle here is 21, also is this one, which means that this arc is also 21. Okay, and now I see that MK is a diameter, which means that arc MJK is a semicircle, which means it measures 180 degrees. Well, if this whole thing is 180 degrees, and this piece is 21, then I can figure out the measure of MJ by taking 180 minus 21. So I know that the arc MJ is 159, which also means that the measure of angle MNJ is also 159. And so now that also means that arc LK or angle LNK is also 159 because they are vertical to each other here. So we can fill all this in. JK is 21 degrees. The measure of angle JNM is 21 degrees. The measure of arc KL is 21 degrees. KL, sorry, that's 159 degrees. JKM, arc JKM. So here's JKM. Okay, so now what do we have to do here? Okay, so J is here, goes to K, goes all the way around to M. So we're going to have to add these pieces together. So I'm going to add 21, 159, and 21 to give me this entire piece. Or what you could do is you could take 360 and subtract 159. You're going to get the same answer. This is 201 degrees. And then the last one, I'm going to erase some stuff because this is getting messy. Arc MKL. So here's M, K. Oh, I went the wrong way. How did I know I went the wrong way? Well, I needed to go from M to K to L, and L was right there. So we'll go M, K, L. There it is. So I want the whole circle except for this 21. So whole thing except 21. So I'm going to do 360 minus 21 and get 339 degrees. Okay, so whenever looking for an angle or even an arc, follow the order of the letters. So M, K, L. So because I went M and then I went to K and realized I had to go all the way back to L, I didn't want to overlap. So I knew I went the wrong direction and had to fix that. All right, let's see what you can do with number 2. Try number 2. See if you can find any semicircles. See if you can find any central angles. See what you can come up with. We'll go over it in just a moment. Okay, so there were different ways to go about solving this one. Before I even started filling in these answers over here, I just started filling in what I knew about my circle. So since this was a 72-degree minor arc, I know that the central angle that makes it is also 72 degrees. And because this is an 87-degree central angle, I know that the arc inside of it is also 87 degrees. So then I start looking for semicircles, vertical angles, things that can help me solve for the missing parts. And I see some vertical angles here. So because this angle here is 72, it means this angle is also 72, which means that this arc is 72. If you're looking for a semicircle, look for a diameter. So here I had found a diameter SV. So I know that arc SWV is a semicircle, measures 180. This piece was already 72. So I did 180 minus 72 and came up with VW as 108, which means that the central angle that makes it is also 108. And then I recognized that I have another semicircle. It's here, the other half. And the whole thing has to measure 180. I already knew this piece was 72 and this piece was 87. So I just subtracted those from 180 to find my missing piece as 21, which means that this angle is also 21. Now I have all of my central angles and all of the measures of my arcs, and I can fill in all of the missing information here. If you got one of these wrong, that's okay. I hope that the explanation here helped clear up any confusions that you may have had. Okay. So now let's practice using those central angles and what we know about semicircles to find some values. So in this one, it's telling me that arc RS is 15x minus 26, and arc ST is 26. And I recognize RT as a diameter, which means that RST is a semicircle. It measures 180. So I can say that 15x minus 26 and 26 together have to add up to 180 degrees. All right, well, negative 26 and positive 26 actually cancel. So I get 5x equals 180. Divide both sides by 5, and x equals 12. The other way that you could have solved this is you could say, oh, well, this whole thing has to be 180. 180 minus 26 is 154. So RS itself has to equal 154. And then solve that equation. You'll get the same answer. Over here, number 6. Let's see here. I know that arc DE is 18x minus 2. Arc DH is 15. And arc FG is 103. Okay, so I actually see some vertical angles here. I'm going to ignore this little guy for just a second. This is 103, which means this angle is 103. So this arc has to be 103. So I can say that 18x minus 2 plus 15 has to equal 103 degrees, since this entire piece has to equal 103 degrees. So that gives me 18x plus 13 equals 103. Subtract 13 from both sides and divide by 18. So x equals 5. We're also going to talk about some chords and the arcs that they make. So we're going to have two chords in a circle that are congruent as long as their corresponding arcs are congruent. Okay, so what that means here is if arc AB is congruent to arc CD, there they are, then our chords are going to be congruent. So I'm going to write AB equals CD. No symbol here means length, so I'm talking about the chords. Then the measure of arc AB will equal the measure of arc CD, and vice versa. Another way that those chords are congruent is if they are equidistant from the center. So the center of my circle here is E. So if EF and EG are congruent, then these chords will be congruent. And not only does EF and EG have to be congruent, but they have to make these perpendicular symbols. Okay, so these are now equidistant. If these are equidistant, then the AB and CD are congruent. So I'm going to write a length of AB will equal the length of CD as long as EF equals EG. If a diameter or a radius is perpendicular to a chord, then it bisects the chord and its arc. So in this picture, EH, here is EH, is perpendicular to AB, and I see that here. Then AF will be equal to FB, so it's cutting these into two equal parts. And the measure of AH will be equal to the measure of HB. So a good rule of thumb, and it's not the best rule ever, but if it looks congruent, there's a very good chance that it is. Okay, so let's look at the next examples. Here I have a chord RS and a chord TS, and the picture is telling me that those chords are congruent. If these chords are congruent, that means that their intersected arcs are also congruent. So arc SR has to be equal to arc ST. And I know that because the chords that make those arcs are congruent. So I can say that 115 equals 7x plus 24, and then we'll solve for x. Subtract 24 from both sides. Oops, I jumped the gun there. There we go. Divide by 7. Okay, so there's x. Over here in example 2, I see that JK is 52 and LM is 18x minus 2. And I see that the arcs that create those chords are congruent. So what I'd like you to do is set up an equation and solve for x. Try that now. Okay, so because the arcs that make these chords are congruent, that means that the chords themselves have to be congruent also. So the length of JK has to equal the length of LM. So I can say that 52 equals 18x minus 2. Add 2 to both sides, divide by 18, and we get x equals 3. Let's look here at number 5. This one's a little different, kind of the same, but slightly different than the last slide. Here I have 2 chords that again are congruent. It gives me this arc, and it gives me the arc inside, but it doesn't give me this missing arc. Okay, well, I know that arc ZY and arc XY have to be congruent. All right, so I know these have to be congruent. I just don't know what they are yet. Well, I know that an entire circle measures 360. So if I do 360 minus 76, that'll tell me what arc XWZ has to be equal to. 284. So I know that from here to here is 108 or 284 degrees. And I know that each of these pieces that make that up have to be congruent. So if I divide 284 by 2, I get 142. So each of these pieces has to be 142 degrees. Okay, well, if arc ZY has to be 142 and it's labeled as 6x minus 20, then I can make those equal because they have to be the same thing. I can add 20 to both sides and then divide by 6. Now, there was an alternate way, and maybe you were thinking of this way. So just in case you were, I want to confirm that you were correct. If ZY is 6x minus 20, you're allowed to also label this as 6x minus 20. And you know that an entire circle is 360. So if you wanted to say that 6x minus 20 and 6x minus 20 and 76 equaled 360 and solve that way, you are going to get the same answer that I got, and it is still correct. So whichever way you want to think about it, both ways are right. Personally, I think this way was faster, but this way works also. Okay, so if they're congruent, you're allowed to make them the same, and then you know the sum of the entire circle is 360. And let's look over here at number 6. It says that MP is 5x minus 34. I know it's small, but I'm going to label it anyway. And PN is 2x minus 4. Okay. Find MP. So from the definition of, from 2 slides ago, yeah, from back here, from our congruent arcs and chords, we know that segments that are perpendicular to these chords are going to be congruent. We also know that they're cutting these chords into 2 equal parts, which doesn't help us with this problem, but that would be helpful maybe in a different problem. So what this means is MP has to be equal to Pn. So 5x minus 34 has to equal 2x minus 4. Let's see, I'm going to subtract 2x from both sides and add 34 to both sides and divide by 3. So x equals 10. X equals 10 is great, but look what it was asking us for, MP. So we need to make sure that we plug that back in for MP. MP is 5 times x minus 34. 50 minus 34 is 16. So our answer is 16. We are going to talk about some inscribed angles. An inscribed angle is different than a central angle. An inscribed angle has its vertex on the circle, whereas the central angle had its vertex at the center of the circle. The two sides that make up an inscribed angle are called chords. The intercepted arc is the arc that lies between the endpoints of the inscribed angle. So your intercepted arc here would be here. That's the intercepted arc. The degree of the inscribed angle is equal to half the measure of the intercepted arc. So this is a little different than a central angle, because in a central angle, the measure of the arc was equal to the angle, and an inscribed angle, the angle is half the measure of the arc. So for angle ABC, its measure will be half of whatever the measure of AC is. So if I tell you the measure of AC is 50, well, then you know the measure of angle B is 25. If I tell you the measure of angle B is 50, then you know the measure of arc AC is 100. If you have an inscribed angle that intercepts your diameter, it will always create a right angle. Okay. And we know that because a diameter is half a circle, so the measure of this arc is 180. So this inscribed angle will always be half of 180, and half of 180 is always 90 degrees. So if you have an inscribed angle that's intercepting a diameter, you can go ahead and say that's 90 degrees. If you have two inscribed angles that intercept the same arc, so for example, I have angle ABD and I have angle ACD. Notice that they have the same intercepted arc. They're both intercepting arc AD. So if they're intercepting the same arc, then those two angles have to be congruent. Okay. So the measure of angle ABD has to equal the measure of angle ACD also. And both of those will be equal to half of the measure of arc AD, since that's the intercepted arc. So let's practice using that. Okay, so here I know I have an inscribed angle. It's inscribed because its vertex is on the circle, not the center. So I'm going to call this just angle X for the sake of my equation. The angle is half of the arc inside of it. So half of 62. So we know that the measure of my angle there is 31 degrees. Over here, we're going to call this, let's see, I have an angle 113, and we want to know what the measure of the intercepted arc is. The angle will always be half of the arc. So ask yourself, what is given to me? Is it the angle or the arc? Well, this 113 is the angle, so that'll go here. and then we want it to be half of the arc. You can give it a variable name if that makes it easier to solve. How do I get rid of a half? Well, I multiply by 2. If you divided by a half, you'd get the same thing. So the measure of this missing arc, this whole thing, DGF, is 226 degrees. Over here, it wants to know the measure of angle PQR, but I recognize PR as a diameter, which means that semicircle has to be 180. So this inscribed angle has to be half of 180 or 90 degrees. Anytime we're intercepting a semicircle, the measure of the angle will be 90 degrees. And we can do that with some algebra expressions too. As long as we remember that the angle is half the arc, that'll help us solve every inscribed angle every time. Now, some students don't like dealing with this 1/2, and it's okay if you don't. What you could do is multiply both sides by 2. And if you do that, you get 2 angles equals 1 arc. If you like that way better, you're welcome to use it. It's the same thing. You're going to see me using the 1/2s. So we have an angle and an arc. You have to ask yourself which one's which. So this 158, that's the arc. 8x minus 9, that's the angle. So the angle equals half of the arc. Well, half of 158 is 79. Add 9 to both sides. Divide by 8. There we go. Okay. The angle is half the arc. If you can remember that, and you can identify your angle and your arc, you'll be able to plug those into your formula and solve. Try that for number 8. Okay, so in this example, the angle was 67 and the arc is 4x plus 58. So the angle equals half of the arc. Don't forget to distribute that 1/2 to everything. Or maybe you chose to multiply both sides by 2 at this step. That would be okay too. We're going to get the same answer. I distributed the 1/2 to everything in the parentheses, giving me 2x plus 29. Subtract a 29 from both sides, divide by 2. If you solved it slightly differently algebraically, but you still got x equals 19, then I'm sure that you did it correctly. Okay. Let's try number 9. In number 9, I recognize that WY is a diameter, which means that arc WY over here has to be 180. Let's see if you can solve this one. Set up your equation knowing this information and solve for x. Try that now. So you should get x equals 7. And we know that half of 180 is 90, or if you see an inscribed angle intercepting a diameter, you can immediately know that it is 90 degrees. So I can say 13x minus 1 equals 90. Add 1 to both sides, divide by 13. Looking at the next one, they don't tell me the measure of AC. What? Oh, but they tell me the measure of these guys. I know that a circle has to add to 360. So if I know this piece is 92 and this piece is 162, I can subtract those from 360 to find the missing piece. So AC is 106. 360 minus 92 minus 162. Now that I know that missing piece, I know the angle, I can set up an equation and solve for x. Try that now. Okay, so we're remembering the angle is half of the arc. In this picture, the angle is 7x minus 10. The arc is 160. So I said the angle equals half of the arc. Well, half of 106 is 53. Add 10 to both sides, divide by 7, x equals 9. All right, so now they're giving it to us as like a sentence instead of labeling the picture. Not a big deal. We'll just have to put the labels in the picture. It says the measure of angle STU is 5x minus 16. So this angle right here is 5x minus 16. And it says the measure of arc SU is 12x minus 50. Find the measure of angle STU. So we'll solve for x, and then we'll plug in and find the measure of this angle. This is an inscribed angle since the vertex is on the circle, and I know that the angle equals half of the arc. So now we just need to solve for x. I'm going to distribute that 1/2 to everything in here. I'm going to subtract an x from both sides. Oh, it's a 12x. Silly me. Let me fix that. So I'm not going to subtract an x from both sides. I'm actually going to subtract 5x from both sides. That way I have some positive x values here. Yep, add 25 to both sides. Okay, so x equals 9 is great, but that doesn't answer the question. So we're going to go back to angle STU, and we're going to plug in 9 for x. 5 times 9 minus 16. Use a calculator if you need to. We get 29 degrees. If you wanted to double check this even further, you can plug your 9 in for the x on arc SU. 12 times 9 minus 50 is 58. 29 times 2 is indeed 58. So we solved it correctly. Down here, number 15. Angle ABD, so that's here, is 6x plus 26. And angle ACD, that's here, is 13x minus 9. It wants us to find the measure of arc AD. Well, now these two angles intercept the same arc. Here, angle ABD intersects arc AD, and angle ACD intersects arc AD. So since they intersect the same arc, that means those angles are congruent. So I can say that 6x plus 26 has to be equal to 13x minus 9. Let's subtract 6x from both sides and add 9 and divide by 7. X equals 5. We can now use that to find AD. So let's take this 5, and you can plug it in for either of these angles. It doesn't matter which one. I plugged it in for ABD. So we can say that 6x, we'll just plug it in. So 6 times 5 plus 26. So we get 56. So this angle is 56. So I can say the measure of the arc, or the angle equals half of the arc. Don't call it x because you already used an x. Maybe use a different variable if you want to just use variable. Multiply both sides by 2. So that tells me that this arc is 112. So my final answer will say the measure of arc AD is 112 degrees. Okay, so we covered a bunch of different types of angles that you would see in a circle. These are not all of them, but it's a good introduction. Please make sure that you are looking through the material for 3.5 and 3.6 on OMHS. Today's attendance word is measure. The measure of a central angle is the measure of its intercepted arc. Measure. You got to spell it right in the attendance quiz. Measure. If you have questions, please make sure you're attending office hours or signing up for small group or just emailing and asking for extra help. There's lots of ways to get help. So if you need it, please reach out. We're happy to help. Have a great day, everyone.